Okay guys, let's get started on the second page of our review sheet. We're going to talk about Boyle's law for just a second. So Boyle discovered that the volume of a fixed mass of gas varies inversely with the pressure at constant temperature. And we're going to see this written as PV equals K, or we're going to see that as P1V1 equals P2V2. And that lets us know that they've got this inverse proportion. As the pressure goes up, the volume's going to go down. If the volume goes up, the pressure is going to be released. Okay, so let's look at the first example that you have on the page. You can read it there. It's a balloon that's filled with helium. It has a volume of 457 milliliters at standard atmospheric pressure. After the balloon is released, it reaches an altitude of 6.3 kilometers, where they measure the temperature. Where they measure the pressure, and it's only 65.5 kilopascals. What's the volume of the balloon at this altitude? Now, the altitude has no bearing here, except that the pressure's gone down. So we don't even need that unit there. I mean, aren't going to use that in our measurements at all. So this is basically this is not basically, it is just completely let me find something to cover this up with. A P1V1 equals P2V2. Oh, my 2 disappeared there. Okay, so what you're going to do is you're going to plug everything in, right? So you get your standard temperature and pressure, and the volume, and then the new pressure at 65.5, and then we're going to solve. So when you run that in your calculator, you're just going to plug that in and chug it right out, and you should get 707 milliliters as the second volume. Okay, so just having, and that's logical, right? Because the pressure went from this to this, so the pressure went down, so the volume should go up. So that's our, is this in the ballpark kind of idea. Okay, so what I'm going to do is you can pause the video for just a second. You try example number 2 on your own, and then I'm going to put up the answer. Okay, all right. Okay, are you back with me? Okay, so here again, this is P1V1 equals P2V2, and we're going to have the pressure and the volume. We're going to put our data in. Okay, so this is going to be the pressure was 623 millimeters of mercury, and we had a volume of 335 milliliters. And you'll see I have a small board here, so I've left all my units out, which is not a good idea for you. You keep them all in. Then the pressure increased. Okay, so it told us that the pressure went up, so we know we're going to get a bigger value. The pressure increased until the volume went down to 252. So you should have gotten, voila, 828 millimeters of mercury as the pressure too. So see, those are really easy, right? We got those chug and plug. We, plug them in. We choo-choo train them out right on our calculator, so we don't have any problem with those whatsoever, right? Okay, so let's talk about Charles' law, okay? So Boyle was working with pressure and volume, and Charles is all about volume and temperature. So he's going to keep the pressure constant here. So that means that the pressure is not going to show up. I mean, if it did show up, it would not change. So theoretically, it's going to be, the P would be the same on both sides of the equation. So we could put it in if we had it, but we don't need to put it in because it's just going to cancel each other out. So our words here are, Charles discovered that a fixed mass of gas, as long as the pressure is held constant, the volume varies directly with the Kelvin temperature. Okay, and this looks like V over T equals the K equals your constant, or V1 T1 over equals V2 T2. Okay, and of course this looks like this right here. Your volume and temperature in the first situation equals the volume and temperature in the second situation. And look at that, my equals sign sort of just disappeared there, got wiped off, okay? So equals that. So let's work a problem here. This quantity of gas occupies a volume of 506 centimeters cubed. Volume unit doesn't matter to us. The temperature is 147 Celsius. Assuming the pressure stays constant, at what temperature will the volume of the gas be? 604 centimeters cubed. The only thing we have to do here, right, is we're going to set this up and just use V1, T1, V2, but what do we have to do? We have to change that temperature to Celsius. So we have to take the 100, whoops, I'm not writing backwards, the 147, right? 147, and we have to add 273 to it, right? Oh, I wrote the 3 backwards, 273. 3. There you go. I wrote it backwards again. Cannot do it. 273. Right, to get us a volume, a temperature, a beginning temperature of 420 Kelvin. All right, so chug that number out and let's get an answer. All right, so it's going to look like this. 506 divided by this. So we're going to cross multiply, right? So we're going to cross multiply here and then divide by the 506 because it's going to be attached to our unknown, right? So multiply, multiply, divide, and we should come up with an answer of 501 Kelvin or 228 Celsius, right? That would be degrees Celsius. Wrote that backwards, degrees Celsius. And this, of course, is Kelvin. All right, see you in a minute for the next page.